Yeah, exponential, not exponential functions. The general equation of an exponential function is y equals a times b raised to the x power, where a is the initial value, okay, and b is the growth factor. And we'll let you know what that means later, okay? All right, if b is in between 0 and 1, if it's somewhere between 0 and 1, then it's called exponential decay, all right? If b is greater than 1, it's going to be called exponential growth. Places where you see exponential growth decay, radioactive decay, carbon stuff, compound interest, all those kinds of things. Rabbit growth, right? Remember that commercial where the guy goes in to write the check for the rabbit, and by the time he finally gets some ID to him, there's like, the store's been overcome with rabbits? No?
Nope.
Okay, never mind. They talk about exponential, at the Humane Society, they talk about exponential growth of cats a lot, because if you just don't leave one little litter unspayed or neutered, you can end up with 40-something thousand cats in like just 6 generations.
Yeah, and they can have cats pretty quick after they're born.
That's what they're talking about. Like over, in 6 years or something, you could have 40,000 cats.
Wow.
And so people just need to take care of snip, snip. Okay, next.
That's great.
Thank you. Glad we could talk about that. Let's talk about b being greater than 1. We're going to look at that graph right there. Again, we want to look at our function here, which is y equals a b to the x. And this graph is of, I guess at the bottom, it says y equals 2 raised to the x power. And that's easy enough to see. So we'll just make ourselves on the side there. You should be able to make like a little t-chart with x and y. If we plugged in 0 for x, what would y be?
0.
No,
Or 1.
1.
Yeah.
Just trying to label my graph here.
Okay.
Okay, so 0, 1, it's going to go right here. All right?
Mm-hmm.
What if I plugged in a 1? What would I get?
2.
2.
Mm-hmm.
1, 2. What if I plugged in a 2? What would I get? 2
X.
squared is...
Or wait.
2 squared
4.
is 4. Okay, we're having a brain moment here. Okay, all right. What if I plugged in -1? What would I get? 2 to the -1 would be 1 over 2 to the first, which would be 1/2.
Mm-hmm.
Okay, now this is not easy to graph, but we're going to do our best. All right? So far, so good? Now this puppy is going to continue to grow up that way. And this one is going to continue to get closer and closer to the x-axis. So now we can talk about domain, range, and all that kind of thing. What is my domain of this puppy? Is there anything that I cannot plug in? I can plug in everything. Therefore, my
Yes.
domain is x is an element of the reals, all real numbers. What is my range?
Y is greater than 0.
That is correct. Y is an element of the reals, and y is greater than 0. Y will never actually be able to be 0. If you looked at it here, your base is 2. The only way I could get to 0 is to multiply by 0. There's no multiplication ever going to happen here. Okay? It can get really close to 0, but it's never going to get there. So I do have what's called a horizontal asymptote here at y equals 0. Okay? So far, so good? Do you see where it says note right below that? Let's go ahead and fill that in. It says the base of an exponential function cannot be, well, it cannot be 0. You can't have 0 for a base. It cannot be 1.
And it cannot be negative.
And it cannot be negative. Okay. If you were going to have decay, you don't get a negative number, you just get a number between 0 and 1. You can't have a base of 0. 0 to whatever is always going to be a big bunch of nothing. Okay? 1 to whatever is going to be 1, no matter what. So you can't have these two, it just doesn't work out. Okay, you can't have a negative, well, that's just basically going to be undefined. All right? So far, so good? So now we're going to look at the graph of the example of between 0 and 1. So on this one, they give us the equation of y equals 0.5 raised to the x. Any number really here works. We're just using 0.5 as an example so you guys can see what it looks like. Okay? If I were to plug in 0, what would I get?
1.
You would get,
1.
yeah, 1.
So 0, 1. Does that look like the other graph?
No.
Well,
Or yeah,
both
yeah,
went through
that
0,
does.
1, didn't they?
Yeah.
Okay, that's about all they have in common right there. We're done. All right, next one, if I were to plug in 1, what would I get?
You get 0.5.
0.5. Well, if I plug in 2, what would I get? 0.25, right?
Okay.
So 0.5, 0.25. This is going to continue to get closer and closer and closer. Let's go backwards. Let's plug in negative 1. Another way to look at that, what's the fraction here?
1/2.
1/2.
So that'd be 2.
2.
And that's one reason I like fractions. I think it's easier to see that 1/2 to the negative 1 is 2 versus 0.5 to the negative 1 is 2. Is that good to go? Okay, and what if we did negative 2?
Negative 2.
That'd be 4.
It would be
Yeah.
4, would it not? So, right here. And this one is just going to keep going up this way. So let's talk domain, range, all that business. Is there any number that cannot be plugged in? Every number can be plugged in, can't
Yeah.
it? So
Yeah.
x is an element of the reals. All real numbers is your domain. What about your range on this one?
Y is greater than 0.
That is correct. Y is an element of the reals, and y is greater than 0. It will never actually be 0. Okay? We have a horizontal asymptote at y equals 0. Okay, we can cut that off.